So the answers to the MYP3 Unit 2 assignment. First question, root 20 times root 5. Well, you had to realize that they could be combined into a single square root of 20 times 5, which means that it's square root of 100, which comes out neatly to be 10, because 10 times 10 makes 100. So the final answer was a nice round answer, even though root 20 and root 5 individually don't have nice round values. Similarly, for the next question, root 20 divided by root 5. So those two things individually don't have nice round values, but you can combine them into a single square root of 20 divided by 5, which is the square root of 4. And the square root of 4 is just 2, because 2 times 2 makes 4. Next question, square root of 2000. Well, you could break the 2000 down into 100 times 4 times 5. So I've broken that down into the square root of 100 times 4 times 5. And importantly, 100 and 4 are both square numbers. So I've tried to take factors out of 2000 that are square numbers. I can then write that separately as 3 separate square root expressions. So that's the same as the square root of 100 times the square root of 4 times the square root of 5. And then 2 of those things come out to be nice round values. The square root of 100 is simply 10, because 100 is a square number, and the square root of 4 is simply 2, because 4 is a square number. So that's the same as that's the same as 10 times 2 times the square root of 5, which can be simplified to 20 times the square root of 5. Next question, 2 sides of a right-angled triangle are 6 centimeters and 8 centimeters. Find the other side. Well, there were 2 possible cases. So in the first case, the missing side could have been the longest side, the hypotenuse, in which case we could have used Pythagoras and said x squared equals 8 squared plus 6 squared. So if the x is our missing side, then in this case the x is the longest side, so the x squared is equal to the other 2 squares added up. So x squared equals 8 squared plus 6 squared, or in other words, 64 plus 36, because 8 squared means 8 times 8, and 6 squared means 6 times 6. So x squared equals 64 plus 36, which is 100. X squared equals 100, so x equals the square root of 100, which is 10. So that's the first case. If the missing side is the longest one, then it would be 10 centimeters. But there is a second case where the missing side is one of the shorter ones, and then the longest side is the 8. So in this case, x squared plus 6 squared would be 8 squared. The 2 shortest ones squared and added up would be equal to the longest one squared, which would be the 8 squared. So more simply, that's x squared plus 36 equals 64. And then taking away 36 from both sides, we would get x squared equals 28. So I've just taken away 36 from both sides to get x squared equals 28. And if x squared equals 28, then x must be the square root of 28, which is about 5.29 centimeters. So if the missing side is one of the shorter sides, then it's 5.29 centimeters. Okay, the next question was about 3 sides of a triangle being 10, 20, and 30 centimeters, and is it right-angled or acute-angled or obtuse-angled? Well, first of all, I'm going to think about if the two shorter sides are 10 and 20, and if it were right angled, what would we expect the longest side to be? So if it's a right angled triangle and you had 10 and 20 as the shorter sides, then we can work out what we expect the hypotenuse or the longest side to be. So h squared equals 10 squared plus 20 squared, which is 100 plus 400. So h squared equals 500. So the longest side would be the square root of 500, which is about 22.36. So if it's a right angled triangle, then the hypotenuse, the longest side, would have to be 22.36 centimeters. But in fact, we're talking about a triangle where the longest side is 30 centimeters. So in fact, that longest side would have to be a bit longer, making the angle a bit wider. So since 30 is greater than the 22.36 centimeters, the angle must be bigger than 90, so the triangle must be obtuse angled. On to percentages. The price of a jacket originally costing €120 is reduced by 30%. What is the new price? Okay, so if we think of the original price as being 100%, then €120 is 100%. We can divide everything by 100 to work out what 1% would be. And then we're interested in finding out what 70% would be. So multiply everything by 70, because if the price is reduced by 30%, then it's only going to cost 70% of what it did before. So we're interested in working out 70% of the original price. So 70 times 120 divided by 100, and that comes to €84. So €84 is the new price. Next question. Cost of a football ticket is increased by 25% and now costs €72. What was it before? Well, we need to be careful here because this 25% is 25% out of the original price and not 25% of the new price, 72. So we need to approach this by saying that the original price was 100%, and then the new price is increased by 25%, so the new price is 125%. It's the original price plus an extra 25%. So €72 is 125%. We can divide everything by 125 to find out what 1% is. And then we're interested in finding out the original price, which is 100%. So we multiply everything by 100 to find out what the original 100% was. So when you do that, you get an amount of euros that's 10 times 72 divided by 125. And that works out to be 57.60. So the old price, before it had the increase applied to it, was €57.60. Next, recurring decimals. We had a recurring decimal 0.240 recurring, and we had to write that as a fraction. So I've called it x. X equals 0.240 recurring, so that's 240, 240, 240, with 240 going on forever. Now I notice that that repeats every 3 digits. So if I multiplied that by 1,000 to get 1,000x, I'd get something that shifted all the decimals up by 3 digits, and you'd still get the 240, 240, 240s in the same place. So we've got a number x that's 0.240 recurring. We've got a number 1,000x that's 240.240 recurring, with the two 4 zeros in the same place. So if we take one away from the other, then we can get 99x equals exactly 240, and all of that recurring bit disappears. So 999x is 240. If we divide everything by 999, we can find out that x is 240 divided by 999, which we can simplify a bit to 80 over 333. So I started with x equals the recurring decimal, and I manipulated it so that I got x equal to 80 over 333. So I've succeeded in converting the recurring decimal, 0.240240 recurring, into a fraction 80 over 333.